Good afternoon, everyone. Welcome back and thank you for joining us. We're glad that you're here. I'm Steve,
And I'm Scott.
and together we are Backyard Musings, the Science and Technology channel.
And today we are talking, or this afternoon, we're talking about the moon, and specifically the far side of the moon. And that's all I'm going to say right now. So,
Scott, I heard that the moon is not made of cheese, but it's made of meatballs, a big giant meatball.
would it be this? It would be a different color. Have you ever shined a light on a meatball? When the sun shines on a meatball, it looks like a meatball. When the sun shines on the moon, it looks like cheese.
I don't know. I'm gonna have to rethink this. I don't know. I wasn't ready for that. You kind of blew my mind right there.
I'm still talking about your Sasquatch Bigfoot theory earlier today. So
The moon's far side is overturning a long-held theory, revealing that the early solar system's asteroid assault may have faded slowly instead of exploding into one catastrophic burst. For decades, scientists have debated whether the early solar system endured one sudden catastrophic wave of asteroid strikes or a much longer period of gradually fading violence. Rocks collected from the moon's far side are now strengthening the case for the second possibility, the gradual fading. Would you like to know more?
rather than pointing to one brief catastrophic storm of impacts, the ancient rocks suggest the bombardment gradually weakened over billions of years as the solar system slowly cleared away debris left behind after the planets formed. That difference could reshape scientists' understanding of the earliest chapters of planetary history. Powerful collisions altered surfaces, atmospheres, and possibly even oceans. On Earth, they may have influenced when the crust stabilized, when environments became habitable, and how conditions suitable for life developed. Well, we all know that. So anyway, that was the season.
Most traces of those events have vanished from our planet. Erosion wears away craters, volcanic eruptions bury ancient landscapes, and plate tectonics continually destroy and rebuild the crust. The moon is no comparable geological recycling system, leaving its rocks and heavily cratered surface as a rare archive of the solar system's violent beginnings.
Research co-author Dr. Fred Jordan from the Curtin University's School of Earth and Planetary Sciences and John D. Later Center said, lunar material preserves evidence of events that occurred soon after the planets took shape. Quote, the moon is like a time capsule. It has preserved a record of events that have been erased from Earth by erosion, plate tectonics, and other geological processes.
Until recently, nearly every lunar sample available for detailed laboratory analysis came from the side of the moon that always faces Earth. Material from the far side provides access to a region with a very different geological history, allowing researchers to test whether conclusions drawn from the near side represent the entire moon. So how did they get the sample? If we've only been on the near side, how did they get the far side? Is it from the Chinese mission?
I don't think anybody else has been to the moon.
Well, China has. I mean, they haven't put people on the moon, but they've landed equipment and rovers and robots and stuff that have picked stuff up.
And how did they get it back?
It's all. I mean, they put it in the vehicle, and then it shoots off the moon, goes back to the orbiter, and then the orbiter comes back to Earth. Except there's no humans involved. It's all automated.
I don't buy it.
Come on, man.
I don't think anybody's been back there.
China has gone back there.
I don't buy it.
That's a fact, Scott.
I think that's propaganda.
No.
Propaganda. Okay. Samples, this is a quote, samples collected from the moon's far side are particularly significant because they allow us to compare two different parts of the moon for the first time. Until now, almost everything we knew came from the side facing Earth. Again, whatever.
Continue with quote. Go ahead.
I was just going to say, I think they went out to like Searless Dry Lake or somewhere out in the Mojave Desert, picked up a bunch of rocks.
And they just filmed on a stage the landing.
Yep, in Van Nuys. Yep. Just saying.
Quote, by analyzing these ancient rocks, we can better understand when major asteroid impacts occurred and how the early solar system evolved. The far side preserves a cleaner record of those earliest impacts because it was much less affected by later geological events than the side facing Earth.
Another quote, these samples are helping us rewrite parts of the moon's history and suggest the early solar system experienced a long decline in asteroid impacts rather than a single catastrophic bombardment. Unquote.
The researchers studied tiny rock fragments containing evidence of impacts that occurred between 4.33 billion and 1.13 billion years ago. Those are pretty exact numbers. I mean, together, the samples allowed the team to reconstruct more than 3 billion years of lunar collisions and track how the bombardment changed over time.
The results contribute to a major debate over the so-called late heavy bombardment, a proposed period when the inner solar system may have experienced a sudden surge in impacts roughly 4 billion years ago. That's billion with a B. Instead of supporting a narrow spike in collisions, the far side rocks point to a longer and more gradual decline.
That extended timeline could also transform how scientists interpret the early Earth because the Earth and Moon occupied the same region of the solar system. Both would have encountered many of the same populations of asteroids and other rocky objects.
Another quote here. The moon and Earth share a common history, but the evidence of early impacts has largely disappeared from the planet. That's according to Dr. Jordan. Going on with the quote, or maybe not. I guess so. Because the Earth and Moon formed together, every major impact recorded on Moon tells us something about conditions experienced by the young Earth.
Okay, continue this quote. Studying lunar rocks allows us to look back billions of years and better understand the events that shaped the environments of both worlds, and helps us understand the role asteroid impacts played in planetary evolution and the conditions that may have influenced the emergence of life on Earth.
The findings come amid a new era of lunar exploration and science, with China's Chang'e 6 mission being the first to return samples from the moon's far side.
Sounds like propaganda, Scott.
Does. It's got propaganda written all over it. So
they didn't want to say Chang'e 1, so they threw a random number like they've had 5 previous missions. Chang'e 6.
Yeah. I don't know. They may have sent stuff there, but I don't know how they got it back. We didn't do that. We never got anything to come back except Apollo missions. So
yeah, because we had humans doing it, pushing the buttons. Now we got the technology that you can just send, communicate wirelessly and land the moon. Okay, make this turn, make that turn. AI,
sorry.
Man.
Sorry, not buying it. So. Okay.
All right, folks. Thanks for joining us. We hope you enjoy your Sabbath tomorrow, and we'll catch you on Monday.
Take care, everyone. We'll see you tomorrow.